Finally, let's look at something called the contact stiffness. In most cases, you can ignore this term in the analysis, but it is good to understand what exactly does this mean. Now, the contact stiffness is the stiffness that is present because of the two contacting bodies or multiple contacting bodies or the same body that is contacting itself at different locations. But the contact stiffness itself depends upon the material stiffness of the contacting bodies. If you have a very large contact stiffness, now let's call this Kc, let's say, and if you have a very large contacting stiffness, then penetration, then it's good for penetration. So let's say not good for penetration, but good for avoiding penetration. However, it is always leading towards convergence difficulties. So proper contact stiffness therefore must be determined from the allowed penetration, and there is no particular rule that you can follow from it. You need experience to understand what this contact stiffness is. Normally, you express it as a scalar multiple of the material's elastic modulus. So I can generally write the contact stiffness to be given as a safety factor, let's say just a factor of E. And you can use it as 1 in general cases when you already have high stiffness, but you can also use a multiple of it. A better idea is to start with a small quantity for this function or this variable for this scalar multiple, and then increase it later step by step to get reasonable penetration. So once you have estimated a certain value of this factor which you want to use as a multiplier, then you can get a better penetration possibility. Now the reason why we use this is we have already seen before that when we define a certain contact condition with friction, we can have stick and slip behavior. And in order to avoid a very sudden increase in the stiffness, we would like to have it to be more uniform increase. And that is what this factor introduces, or this multiplier takes into account the strength as well. So in the case of tangential stiffness, for the slipping condition and the sticking condition, you can use also the shear strength, which can be used with a multiplication factor as well. However, you do not have to take care of all these things for every possible analysis. In case you have a very high stiffness, so if you get a very large tangential stiffness, then your contact surface will start behaving like a rigid body. But if you have a very low tangential stiffness, then you will have too much sticking condition. So you will have too much inaccuracy which could be introduced into the model. And then you have to use a large amount of damping or even automatic stabilization to take care of the problems. But by no means does it guarantee that you will still get the best results possible. So let's do a small recap about the entire conditions of contact. So as I've mentioned before, you have different kinds of contact that can happen, flexible and rigid or both. And depending on this, you can have different contact conditions which may or may not include friction. So you can have welding contact, you can have stick-slip conditions, you can have rough contact conditions. And in order to carry out any kind of analysis, you need to first search for contacting bodies. Then you need to apply contact forces, after which are depending on the slave and master definition. So that means we need to go back to searching for our contact bodies. So as a user, it is our responsibility to make these contact bodies known to our analysis. And if we know these contact bodies to be slave or masters, then it is even better for the analysis to decide or take care of all the limitations during the computation procedure. Once the formulation has been carried out, then this formulation is based on the tolerances for contact surface search that we have defined along with the increments. That is where we need to be careful about the increment size that we allow in the job. In order to run contact analysis, we do not need to have nonlinear geometry on in all the analysis programs. So you can always check within the online documentation of the software that you are using whether in order to use contact you need to have the nonlinear geometry function switched on or not. Now, the definition of your flexible and rigid bodies is also going to be dependent upon your contact stiffness, which is directly derived from your material stiffness. So, it is indeed very important to decide first of all which is the master, which is the slave, and based on that the contact stiffness is also going to be evaluated and gives a better result for the analysis in a better prepared environment.